Okay, everyone, I think we can get underway. My name's Siobhan Lavelle and I'm a member of the ASHA committee. I'd like to welcome you to tonight's seminar, which is part of the ASHA online series, but also specifically being held tonight as part of National Archaeology Week. I'm on the land of the Darug and Gundungurra people, and ASHA acknowledges the traditional owners of country and recognises their continuing connection to land, sea, sky, water, and community. Recognising where we stand is but one of many acts acknowledging injustices and committing to acts of reconciliation. We pay our respects to Aboriginal and Torres Strait Islander cultures, to other First Nations people on the lands on which we meet this evening, and to elders past and present. Now, we're very fortunate that for National Archaeology Week, we have Professor Susan Lawrence available to speak with us this evening. Susan teaches archaeology at La Trobe University in Melbourne. She's the author of 7 books and many other book chapters and scholarly articles. She's been a member of the Heritage Council of Victoria's Archaeological Advisory Committee, and she is a fellow of both the Australian Academy of the Humanities and the Society of Antiquaries of London. But most importantly for us, Susan is a past president of the Australasian Society for Historical Archaeology. And I can tell from the roll-up that everybody earnestly read the information on our website. So I'll hand over to Susan to speak to us shortly, but I'd just say, could you keep your questions until the end? And we're hopeful that there will be time for Susan to answer any questions you have at the end. So over to Professor Lawrence to speak with us about characterising mine wastes as archaeological landscapes. Thanks.
Thanks, Siobhan. And thank you and to Ellie for both the invitation and managing all of the logistics to make it happen. And thank you everyone for showing up to hear about mining waste on what is a very cold winter evening here in Melbourne. I will start sharing my screen and we'll get on with it here. There we go. Okay, so hopefully you can see that now. So yes, I'm going to be talking tonight about characterizing mine waste as archaeology, basically. I'm going to talk about 2 things. First of all, the Loddon River, and then mine waste. And I'm going to do that to juxtapose them and challenge you to think about the way that off-site mine waste should be thought about as part of archaeology and what happens when we do that. If we understand these landscapes as anthropogenic and part of the archaeological record, what follows from that? And one thing that I'll be suggesting is that when we think like a river, which is what this talk is about, then it allows us to link the upstream source of waste with downstream places where the waste ends up. And we can think about these things in a much broader way. So before I get into all of that, though, I would also like to acknowledge that I'm on Wurundjeri Woiwurrung country here this evening talking to you, but the research that I'm going to talk about is on the country of Jara people, Jandak, up east of, or rather west of Bendigo, and I'll show you a map in a moment. So I pay my respect to all the Wurundjeri Woiwurrung elders, but also Wurundjeri or Jara elders past and present, and acknowledge that mining has exacted a terrible toll on their country in many parts of Australia, but definitely Jandak still shows many of those scars. And I pay my respects to Jara people who are working very hard to try and heal that country today. So this evening's talk is really drawing on a long-term research project that Peter Davies and I have been involved with now for well over a decade. We've had a number of ARC grants. We've been very fortunate to keep getting funding. We started with a couple of simple little questions, we thought, way back in 2010. We're able to get some money. That rolled on into another project, and then now another project that Peter and I are still working on. We've been able to work with lots of amazing people that I will thank properly at the end. But basically, it's a long-term research project. It's very multidisciplinary. It's been looking at a number of river systems around Victoria, and they're all circled there on the map from the ovens up in northeastern Victoria. We're just starting work on the Goulburn in sort of central eastern Victoria, Walhalla and the Thompson River in Gippsland, the Yarrowee River south of Ballarat, and tonight's talk, which is about the Loddon River. It is very multidisciplinary. We've used lots of different techniques to address the issues we're interested in and the questions that we're trying to understand. These are some of the pictures of our various teams at work. So we've had some fantastic geomorphologists who understand how rivers work. That's Ian Rutherford and James Grove and Mark Macklin from the UK. We've got Ewan Sylvester and his student Francesco Colombi, who are geochemists and really understand arsenic. We're now working with some more geochemists, Larissa Schneider and people at ANU who are mercury specialists, and Anna Lintern and her students at Monash, and as a hydrological engineer, and understand the distribution of pollution. And of course, the archaeologists, that's Greg Hill and Jody Turnbull, looking very earnestly at some stratigraphy that has been exposed. So with all these different people, we've used archaeological techniques, doing lots of fieldwork, recording sites, looking at stratigraphy, doing lots of mapping with GPS and layering of historic GIS things and maps from the archives. Peter has spent lots of time going through mines department records and newspapers on Trove and so on, and collating information from there. We've done cores. The chemists have analyzed things, and the picture of me at the computer, that is me actually driving the Australian synchrotron. So I love that photo. And turns out you just have to push some buttons on a computer. It's pretty straightforward, but we were able to use that as part of our research too. So it's been a huge amount of fun doing this long-term and multidisciplinary project. What's it been about? Well, that's what I'm going to talk about tonight. And this is a case study really from one of those rivers that we've been looking at. This is the Loddon River. The Loddon is not only on Jarrah country, but the bits that we're really interested in are Jarrah on Jandak. It starts in north central Victoria, to the north of Melbourne in the hills of the Great Dividing Range, and it rises around Daylesford and Castlemaine. You could see that down at the south of this picture. It flows north and eventually joins the River Murray. So it's draining those Central Highlands. It's a typical river of the Murray-Darling Basin. It's very, it's fairly long. It's one of the longer ones in Victoria, certainly, but it goes pretty slowly because it moves through very low relief. Once it gets out of those highlands, the ground is pretty flat. So most of the rivers in the Murray-Darling, they can carry a reasonable amount of water, not a lot by global standards, but they don't always deliver a lot of it to the Murray because it gets distributed along the way. And that's certainly the case with the Loddon. Before the gold rush and before the European invasion, it was a classic chain of ponds kind of river with lots of lovely little water holes along it and wetlands and so on. And these days, it's got lots of different uses. In the high country of the Dividing Range, there are still bits that are forested. That's the Wombat State Forest near Daylesford. It's got those beautiful goldfields towns. This is Castlemaine. And then as it gets out onto the low country, it is part of the big irrigation agriculture network that is the Murray-Darling Basin today. So it's both fed and feeds a lot of irrigation channels that run through that flat country, and that water is used for irrigating crops and grazing and orchards and fruit production and so on. So that's kind of the Loddon in a nutshell. Recreation and forestry in the high country, and then irrigation agriculture down in the low parts. Mostly the major towns are on the tributaries of the Loddon rather than the river itself. Okay, so that's the river. Now I'm going to turn our attention to mining waste. And for those of you who are not complete mining nerds like me, I thought I would just start with some definitions. So one of the terms that gets used in Australia for mining waste is mullock, and I think that's a Cornish term. Basically, it means overburden, which, archaeologists will understand. Overburden's the stuff that you have to move in order to get to what you're interested in, and mining is no exception. So these are some photos of some of the mullock heaps around Victoria. Bendigo's last surviving mullock heap, much of Bendigo and Ballarat used to be covered by these huge piles of mining waste. You can see the car there for scale. These are literally mountains of waste. Here are piles of mine waste that loom over the town of Walhalla from the big mines there, the Long Tunnel and the Long Tunnel Extended. They are very dominant features of the landscape of that town. And these other piles of mine waste are around Creswick and Smeaton on the Very Deep Leads system. And they are just sitting there still on the landscape. They're very prominent. So that's mullock. That's the stuff that you dig to get to the gold. And this is just an example of one of these big underground mines in full swing. This is one of the mines in Ballarat, 1910. And you could see these big piles of waste material there. So that's really just the country rock of whatever the geology of that area happens to be. Another relevant term to think about is tailings. And tailings is the material that is the processing waste. So this is the stuff that is left after you have separated the golds. And I should have clarified at the beginning that I am talking about gold mining. That is the only kind of mining I'm talking about tonight. But the issues, I think, are relevant for any kind of mining. But in terms of the industrial processes, we've got the overburden. All kinds of mining have overburden, and the tailings is what's left after you've extracted whatever it is that you're interested in. So in the case of the gold mines, after they get out the gold, and these are some piles of tailings that also just sit around on the landscape. So here again, we've got one of the mines out there at the Very Deep Leads around Smeaton. And these other two, one is at Chewton, one is at Rushworth. You can see the people in there for scale. All of this stuff around there that you could see, that disturbed ground, that is a pile of tailings from the Forest Creek gold mine, or the Garfield Wheel. Some of you might know it. And down below as well, these are tailings from the Balaclava mine at Rushworth. And that's a trail bike track going over it. And again, quite substantial features on the landscape. So this is the stuff that has been through the crushing machines. And this is what the crushing machines looked like back in the day. The Port Phillip Company at Clunes, this is in the 1860s. You could see all their stamp batteries there. They are a big mortar and pestle, basically, that goes up and down and crushes the rock. And then all of the fine sands and silts that are left get washed over this table down in front. That's covered with mercury, and the water and the silt flowing over that, the mercury kind of grabs the gold, and the gold sinks to the bottom, and then all the sand and silt flows over and is your tailings. So that's the difference between mullock and tailings. When we're thinking about these tailings, usually people recording archaeological sites don't pay too much attention to them, and I'm going to suggest maybe we should. One of the things that the tailings can tell us about is how that ore was actually treated. And you can see here, these two different piles of tailings are very different in color. And that's because they've been treated in a different way. The calcined sands have been roasted and heated, and that's why they're that reddish color, whereas the golden ones have not been treated. They have, however, or they haven't been heated, they have, however, been treated with cyanide. And it is important to note that all of these tailings are quite possibly going to have some kind of level of chemical contamination in them. which is definitely something that is not really well appreciated in the Victorian landscape. The mullock piles, probably less, because that's just the rock itself. But the tailings that have been treated could have chemicals associated. The mullock itself can also tell us things, though. If we look at this pile, also from the Australasian #2, you can see the different colors that are represented in that mullock. And that's actually telling us about the daily work of the miners underground, bringing up their ore carts and tipping them over the side. And as they are working through the different layers in the stratigraphy, that rock is different colors, it's composed of different materials, and we can see that their actual work there in creating that pile. So these are very human objects, even though they are this large scale stuff. Okay, now all of this that I've been talking about is maybe not what we typically think of as archaeology on a mine site, where you're looking at the machinery foundations or whatever. It is still part, however, of that mining story, but it's also on site. It's where the mining took place. So in that sense, it's quite familiar. It's the sort of archaeology that we would all expect to do. If we think of mining landscapes in this sense, what we're really doing is we're kind of linking together several places that have similar remains. So on the left, that's the mining landscape of the buried deep leads around Creswick and Smeaton, showing one of the mines in the foreground, the Berry #1, but this landscape is comprised of about 24 of these mines that are in close proximity, and that's what consists what we think of as the landscape. Another example of a mining landscape that's really just a whole lot of individual mines lumped together is Old Lead at Denali on the right-hand side. And that is a much earlier kind of mining from the early 1850s. And that's a whole lot of individual shafts and the mullock that is lying around those shafts. And the proximity, again, of all of those shafts and their mullock creates this extended landscape. But it's still really on-site archaeology. What I want to talk about for the rest of the evening is really off-site archaeology. Archaeology that we find away from the kind of the center of activity, but things that are still part of human behavior and human activity. And this image here is from 1909, was taken by a gentleman working for the Sludge Abatement Board, which was a government body who were charged with compliance. Their job was to make sure that mines were not releasing their tailings into the environment. And as you can see from this picture, these particular mines were in fact releasing their waste into the Lee River south of Ballarat. And all of the gray stuff that you can see there is mine waste that has washed down from the mines at Ballarat. So it gives you a very stark indication of what that this is really still, it's human, it's anthropogenic, it's a long way from the mines. Shelford is about 40 kilometers downstream from Ballarat, but they've still got mining waste there. So this is, really still part of those mining landscapes of Ballarat, even though it's a long way away. Why do we have all that? I've been talking about underground mining, where most of the waste material does get piled next to the shaft, but a lot of mining that was done on the gold fields in particular was alluvial mining. And they used water as their main way of separating the gold and the surrounding rock, mostly gravels, not actually rock, but gravel and sand. And because they were doing that, they didn't stack their overburden neatly next to the holes that they were creating. They used the water to wash the overburden downstream. So the pictures on the left show you a group of Chinese miners at the top and a group of European miners at the bottom that are doing different kinds of alluvial mining. They are using the water to remove the overburden at the same time as they're processing the gold. So in this kind of mining, there's no real distinction between the tailings and the mullock. And what you're left with is a huge hole, and this is one of our colleagues, Darren Baldwin, standing at the bottom of this mining void. And all of that material up above Darren really is the overburden that was being washed and removed to get to the gold-bearing layers. So huge volumes of soil that are involved here, and none of it left on the site. That was what first made us think about this. We would go to these huge voids, but there was no mullock. Where's it all gone? Well, it's become waterborne. It's gone into the creeks. And I have probably, you've heard me talk about this on previous occasions, but it gets washed down the waterways. And that went on in Victoria for about 50 years, from the early 1850s right up until just before the Second World War. We saw that photo from 1909 of material still being flushed into the waterways. So what we realized when we went to have a look at rivers was that we can still very clearly see the evidence of this sludge in the rivers. And this is my colleague Ian Rutherford standing here, where he's got his hand. That is the boundary between the original floodplain sediment in this creek, which is downstream from Beechworth. And everything up above Ian's hand, that buff-colored material, is mining waste that's been washed down, in fact, from holes very much like those that we just saw in the previous slide. So all of that above Ian is mine waste. And we can see that in lots of other rivers around Victoria too. Pretty much every river we've gone to look at, we've been able to find this evidence of mining waste. Here is actually the Loddon, which I will get back to in a minute. The Loddon at Carisbrook, and you could see the buff layer up above there. It's much shallower than the one that Ian's pointing to, but that is the mine waste there on the floodplain at Carisbrook. Everything down here, the grayer material, that's the original floodplain. And the image on the right is Yarrowee Creek, which is what the Ballarat waterway is called up closer to Ballarat. It turns into the Lee further down, but this is just probably 10 kilometers south of Ballarat. And there's that buff layer again, a very thick deposit of mine tailings sitting on top of that gray floodplain soil. So all of this offsite archaeology basically is these floodplain deposits that they're an alluvial formation, but they're also anthropogenic. So let's go back to the Loddon and have a bit of a closer look at mining in that catchment. There's a big diversity of mining in different parts of the Loddon. You could see the Loddon itself is the blue line through the center of the map that turns and goes up to the north toward the Murray. It's got lots of tributaries. It's really quite a complex river system. And all of those tributaries drain areas with all of this yellow, which is the gold-bearing ore. These are all the goldfields areas. And you might recognize some of these names: Bendigo, Castlemaine, which is also the Mount Alexander field, Dalesford, Creswick, Malden. These are all quite large and rich gold fields, gold deposits. Clunes is a tiny little yellow speck. It's a much smaller gold field, but what was there was very, very rich at the time. So you've got all of these gold fields being drained by pretty much every single one of the tributaries of the Loddon River. So right away we could see, that there's a relationship here between the two. Up at the top photo is the Beehive Mine kilns at Malden. This is one of the mines that was a big underground mine in the 1860s and 70s. Malden was a big center of underground mining, mining the quartz deposits. And they were the chemistry of the ore was complicated, so they were trying to figure out how to separate it more effectively. And that's where they were doing this roasting or calcining. So these are the kilns that were used for roasting the ore before it was crushed. So you've got those up at Malden. Here at Castlemaine, this is the remains of the Garfield Wheel, which was the largest water wheel in Victoria, if not the Southern Hemisphere. I'm forgetting my stats at the moment. But it was this huge water wheel that was used to power the stamp batteries at the Forest Creek Gold Mine, and I showed you some of their tailings a few minutes ago. So that's the Garfield Wheel there at Castlemaine, also a big area of underground mining, but smaller scale mines, rich, but each individual mine was on a smaller scale. And the bottom image here is in the Creswick State Forest. This is a typical void left by that alluvial mining. And you could see the piles of mullock on the base of this great big hole, but most of the material that's there has been washed away. So there's a combination in this catchment of hard rock underground mining at lots of centers, the alluvial mining at lots of places, and those very deep leads there all around this area as well. So we've got that kind of mining as well. So a real diversity of mining taking place, and that means that all of the tailings are going to be a bit different as well. As part of our project, we thought, well, we'd like to know a lot more about this because it was such a prominent mining area and at different times had the world's richest mines. Both the deep lead mines were the richest in the 1870s in particular, and the Bendigo mines in the 1880s. So this is a very rich mining area, so we want to know more about it. So the first thing that we did was to try and calculate the actual volume of tailings that were going into the Loddon from all of this different mining. And this is the work that Peter Davies did initially in the archives, going through the mines department records and calculating based on the information in there how much waste was being released. And we did that for each of the separate goldfields, which we then translated into catchments or subcatchments of the Loddon. And that was stuff that Greg Hill and Jody Turnbull did, turning the way that the mines had recorded it into information that we could match with the water catchments themselves. So once we had done that, Peter estimated about 80 million cubic meters of tailings from the mines along the Loddon. And he's put that on these pie charts. This is a map that Greg Hill did. And you could see the size of the pie is the relative quantity of tailings that have gone in. So Castlemaine had a lot of tailings go in, less from places like Dalesford and Malden and so on. But still, quite a few. And the color refers to whether it's underground hard rock mining or alluvial. And you could see that most of these tailings are alluvial. So they're from the big voids being created. But it's important to note that actually there is a contribution from the quartz tailings as well, from those crushers and the batteries. They are also sending their tailings into the river. So it's this combination. And again, on Greg's map, the gold fields are the kind of bluey area, and the river is in gold. And the extent of the gold on the river actually is where we found evidence of tailings, and also where the historic records indicate there was tailings. So it gets down about as far as Inglewood on its way to the Murray. So thinking about this archaeologically, we can go back to the very basics of archaeology by, Albert Spalding back in the 1950s, when he talked about the dimensions that archaeologists are interested in, and we are interested in measuring variability in space and time and form. So what does that look like with these tailings? Well, we can see the extent of these tailings in space. We can go and stand on the riverbanks and we can observe the presence of these tailings, and we can see their spatial extent and how thick they are and how far downstream they get. So we can measure that dimension of space. This is looking at those deposits as they move downstream. So here at the bottom, that's a deposit on the riverbank at Newstead, which is downstream from those big alluvial tailings releases at Castlemaine, and you can see how thick the deposit is there. The next image is Francesco Colombi with a PXRF taking the readings for arsenic on another very thick deposit of tailings that is here at Tullaroop Creek, and that's getting all the tailings from Maryborough and Clunes as they come into the Loddon. And the top one is at Bridgewater, and you could see that by the time it gets down there, that deposit is much thinner. So it's starting to taper off. Most of the tailings are in the upper and middle parts of the catchment, and fewer and fewer of them as it gets downstream. So there's that shape of the tailings that we can see as well. We can also look at them in detail using our archaeological skills to look at the stratigraphy, and we can do the profile drawings. This is stuff that Jody did, and we could see the different kinds of deposit that's there. And the photo is interesting, the one on the right, because that's a close-up of one of these exposed banks of tailings. And what you can see in there is the really fine laminations of these silts and clays. Sometimes they'll be interleaved with gravels. The profile drawing on the left shows where there's gravel and sand interleaved with the silt. And that's again telling us about really the daily practice of the miners letting their tailings go from their mines on a day-to-day basis. And we can see in the record people talking about, oh yeah, on Mondays, the river would be a bit clearer because the miners had a break. Sunday was their day off, so they weren't sending the tailings in. So Monday it was a bit more clear. And so you can see these, these fine laminations of that daily and weekly work that people are doing there. So these deposits have physical characteristics that we can identify. They have these laminations, they have, cross bedding, they're alluvial deposits. They have the interleaving of sand and gravels and so on. And they have this distinctive buff or pale color as well. So they have those physical characteristics. They also have chemical characteristics, and this is from Francesco's thesis that he's just handed in, and he's looked at the distribution of arsenic in these tailings, and again, they've got very high levels of arsenic, mostly down at the bottom, which is good news because that's less accessible biologically. So they're mainly down at the bottom of those soil profiles, but they are elevated compared to the underlying floodplain sediments, which are the blue down in the lower parts of those sections. So that's another characteristic of these materials. So we can look at space, we can look at form, and we can also look at time. Because this is from the recent past, we've got ample documentary evidence about these events and these things happening that we can look at. There were thousands and thousands of reports in the newspapers from the 1850s on of people complaining about sludge and what was going on. There were numerous government inquiries and royal commissions and so on into it. So an abundant documentary record that helps us to date very precisely, when this deposit is being formed. It's not just a generic alluvial deposit. It has this history to it as well that we can see in the documentary evidence. And we can also see it in the field because of the artifactual evidence that is embedded in them too. It's not uncommon for these kinds of alluvial deposits to have artifacts embedded in them. And this was my favorite example from at Newstead. This is James Grove. Just about where where his hand is where these fragments of pottery came from. So way down at the bottom of that sludge deposit. And of course, you probably are all recognizing that is the Chinese, the Jianyu, the stoneware or coarse earthenware jars that the Chinese miners used, and on the other one there is a little bit of fiber blue transfer print, both very characteristic of the late 1850s, early 1860s. Noticeably, there is no Chinese encampment anywhere near this location, so this stuff has all washed 10-20 kilometers downstream with the sludge. So we've got those artifacts there as well. So these mining deposits are very identifiable. They're very consistent. They're also more generally part of something called post-European settlement alluvium. And this is a set of deposits that river scientists have identified and known about for decades. It's any kind of widespread sediment deposition from anthropogenic activities after the arrival of Europeans. So they talk about Pisa, quite frequently as something that occurs in lots of river systems, but they are not very good at pinning down the actual causes of Pisa, and they talk about it in quite generic terms. What we've been able to do with our research is to say, well, some of this stuff is very definitely caused by mining activity. So it's these mine tailings are really a subset of this much larger, really geomorphological phenomenon. And there'd be lots more research that could be done on Pisa more generally. But just looking at mining, so if we think of this mine waste, we've got now really an anthropogenic landscape. So it's archaeological. We can look at it using our archaeological skills, and we can identify that distinctive form, the time that it was created, and that regional space that it occurs over, and just the scale of it. Again, this image is of a tailings dam that was built at Newstead by the time they did have to start keeping their tailings on site. So one group of miners built this dam, and just as a scale, I think that's Peter, who's well over 6 foot tall, there to give you an idea of how big this deposit is. So we've got these very classic archaeological characteristics that we can identify, but it's off-site. It's not at the mine. And people were always saying to us in this project, oh, there's no mining around here. No, that's true, but you've got the legacy of mining here. So it is still part of that mining system. So if we think of it as an anthropogenic landscape, we can see the way that we can contribute to understanding it because of our archaeological knowledge. But it also challenges us as archaeologists to think at a more extensive and regional kind of basis. We can then link these upstream activities of the mining with the downstream consequences of those activities. And that's a really useful way of thinking about all kinds of archaeological things. How does it all link together on this regional scale? It's also a quintessential example of the kind of entanglement that people like Ian Hodder talk about, where we've got this intermeshing of human activity triggering changes in the non-human world, and humans then respond to that, and so on. And of course, people have been responding to this mine waste and these deposits for a very long time now. And it's really, part of, we can think of it in terms of network theory as well, and the networks that are created between the areas of mining and the areas of waste deposition, all of the resources that circle through that, the people that are involved, the networks of communication and mining skill and technology, and the litigation and the legislation and so on. So it's, we could think about these very prosaic landscape features in all kinds of different ways. But it also has, lots of other ways that it challenges us to think. So thinking like a river, I've talked about. One of the things that I'm very interested in at the moment is that just in the last couple of years, A lot of European archaeologists and some from North America as well have started to really talk about something called unruly heritage, which is stuff that we inherit, but we don't really want it. We didn't want to keep it, unlike, the other stuff that we think of a lot more. And they also talk about this being kind of involuntary heritage that we've inherited and have to deal with. It's ambiguous, it's accidental, both in its creation and the fact that it is still there. And Hayden Stewart actually has gone so far as to say that the afterlife of this kind of industrial waste is one of the defining characteristics of the Anthropocene, that we are dealing with this stuff all the time. So I see I need to talked too much about mine waste, not enough about the implications, because it does have implications. It's unruly, but also we've still got it. What are we going to do? I mentioned that contamination. How do we deal with that as part of our heritage sites and in our work practices when we're working in these places? Devon Consols in Cornwall was a copper mine that flipped itself to become really a mine to create arsenic when arsenic was a desired product. So you've got that legacy of this contaminated waste. What do we do with it? It also has implications for cultural heritage, because we know, and Greg's done a huge amount of work now, that this landscape feature has buried earlier landscapes underneath it, and those landscapes are still there. They are still reasonably intact, whether it is Aboriginal landscapes or whether it's the landscapes of the early mining period. This is, one of those really early mullock piles that was then buried by later mining waste. So we've got implications for how we manage cultural heritage in these places, and things like regional planning. On the left, that's me standing there looking at this exposure of sludge. All that paler stuff at the top is the sludge. That was in 2019. We went back to that location just a few weeks ago, and now it's got houses all over it. And they've actually dug some of that stuff out to make a little pond. I don't know how much, they did in their soil testing and their chemical testing, what they've done there, but and also their archaeology of what, how deep those footings are on those houses. But those people are now living in that environment, and Ballarat and Bendigo and these other places, they're real regional growth centers. So it's something to think about. Also implications for scientists who are involved in stream management, because this deposit of tailings has created an ongoing process in the rivers. It has changed the way they behave, and that will continue. They're not going back to their original state. So in some cases, they've got sand slugs in them that are the tailings that have clogged the river and caused the rivers to change direction, or just not flow as efficiently, and I could go on about that. Also stream incision. The reason that we could see all of these amazing stratigraphic profiles exposed in the side of these streams is because the streams have incised because they stopped getting the mine tailings, basically. So the mine tailings triggered first filling up the rivers, but then incising the rivers. So they're causing ongoing erosion, even now, 100, 150 years after that original deposit. So understanding what is causing that is a really important thing for stream managers to know. Biodiversity, another thing. These are two parts of the Loddon that have both been covered by sludge. And these are, riverbanks and riverine environments should be the richest part of your landscape, the richest ecological zones that you have. But you can see there, that is just monoculture grass, basically. There's not really much happening there at all. That's because the seed bank is, a meter below all of that sludge. So there's implications for biodiversity and trying to regenerate some of these environments as well. And of course, that's what JARA are trying to do, and I acknowledged them at the beginning. This is Wanyaradum, which is frog ponds, an area along Bendigo Creek where they have been trying to heal country and put in indigenous plants and use the wetlands as a wastewater kind of treatment, stormwater treatment for the local suburbs. So, lots of healing country work that's being done. And so, Jara and other traditional owners need to know about this as well. Okay, that's me done. A little bit late, sorry, Siobhan, but I'm finished. And oh, there's the book that I needed to mention as well. If you are interested in learning more about sludge, yes, you can get the book. So that's all. I will stop sharing.
Great, thank you very much, Susan. Much appreciated. And I'm sure that what you have told us has provoked some questions in people's minds. They can either pop those questions into the chat, or if you're not comfortable doing that, you can try and raise your hand virtually or by putting your cameras on. But bear in mind, there's 4 screens of you that I have to go through to find you. So, so if you have a question, perhaps if you can deal with the technology by putting it in the chat, that would be fantastic. While we just wait for those to pop up, I don't need to ask you something, Susan, like what made you study this topic, because as you said, it's come out of a very long period of work and analysis and thinking about mining, and then the kind of, I was going to say flow-on effects, but that just makes it sound like bad puns. I suppose one of the questions, though, did anything surprise you in doing this latest research? Were there unexpected things? Right.
Everything about it has surprised us, Siobhan. and that's, probably all of us have experienced people saying, oh, why do you do historical archaeology? What could that possibly tell us? We don't know from documents. Well, what I respond, this project came entirely because we were attentive to the material record. It was looking at water races on mine sites and wondering, what were they there for? Why were, what were they about? Where did they go? Where did they come from? Wanting to answer those questions about the physical features of the archaeology that led us to this whole amazing story of sludge and mine waste and contamination and all the rest of it. That, yes, we went to the documents to answer some of those questions, but it had been sitting there in plain sight in the documents for 150 years, and the historians had not paid any attention whatsoever. It took the archaeologists and that attention to the physical to actually start unraveling this. So I'm constantly surprised. I did not expect, when we applied for our first grant, that 15 years later I would still be sitting here talking about it. Yeah, it's endlessly fascinating.
Yeah, great. Thank you. We do have a question. I'm not sure if you can see the chat, Susan. Are you able to see that?
Did I saw it and now it's disappeared. I should be better at finding the chat.
Okay.
Oh, there we go. Now I can see it. Okay. So this is from Kristen.
Yeah.
Processing and treatment. Elaborate what is indicative of cyanide in the goldish sands. Are there other obvious physical signs of treatment that archaeologists working on floodplains should be looking for? Good question, Kristen. That slide is a bit yeah, it's misleading, because the gold color is not the presence of cyanide. The gold color was really the absence of the heat treatment. So there's nothing visually about the tailings themselves that will say that they're contaminated. What you can do, though, is to distinguish between tailings, which is going to be the finer stuff that's been crushed, and mullock, which is the the lumps of gravel and rock, and that's probably not going to be contaminated. But if you've got the fine stuff, then it could be. Cyanide treatment also is very on-site and localized. They did it in big vats, and they emptied out the vat and piled all that pile of sand next to the vat, and they brought more and put it in their vat and stirred it around and emptied it. So the cyanide sands are probably going to be on site. You're not going to find them somewhere else. But the arsenic and mercury could be a long way away. We don't know much about mercury yet. We're just starting that research. So I'm not entirely sure, but we have certainly learned that there is possibility of arsenic. So PPE is my advice to anyone who thinks they might be working with places where there's tailings, because it's in the fine dust. And, as we know, when we're sieving, that's what we get, is fine dust.
Thanks for that. The chat is kind of starting to fill up with questions now. We have another one there, which is a question about, do you have many sites that display herringbone tailings from alluvial sites, as seen in New Zealand? Yeah.
As seen in Neville Ritchie's classic work there in Otago, where they have no tree cover, so it's easy for them. Cheaters. Look, there are some in Victoria. I don't think they're as common as they are where Nev was working there in Otago. We have seen some up in the Northeast, and we haven't physically seen them in person, but we've got amazing LiDAR images that show very clearly that there are herringbone tailings up in the Minamata area. And I saw that Christine DeVeth is in the audience, so she might have seen them in person. So there are some, but the places, yeah, all the sites that I've been to in central Victoria, I've not really seen anything like what Nev saw there.
And we've got another one, which is a great one, which is, do you think that there is an appetite at Heritage Victoria to list these sludge deposits?
Probably not. No. I'll speak on behalf of them. The waste, that's on site, yes, that is definitely, when it's noticed, it is recorded as part of the site and is on the VHI for that. The off-site stuff that is, these huge extensive landforms, that's going to be much more difficult to list as an inventory site, and I don't know that there'd be a lot that would be gained by doing that, to be honest. It's really more about doing predictive modeling so that you are aware of what might be underneath it and whether the development that you're involved with is going to be deep enough to have an impact, or whether your development's shallow and actually the underlying stuff is going to be protected by that. And knowing that, if you're doing test pitting, you should go deep enough to find what's underneath. So it's more kind of using it in a predictive modeling sense than necessarily listing them as sites. I mean, this is the problem with offsite archaeology, is how do you draw a boundary around it? So,
yeah, look,
very hard.
There's a kind of allied question to that one, which I'll go to next, which is, what is Heritage Victoria's take on sludge from a legislative perspective? And again, you may want to defer that to the regulator, but
yes. So I'm not quite sure what you mean by from the legislative perspective. They're certainly aware of sludge and using it in a predictive modeling way. They are not trying to protect sludge and to list it from that kind of view and give it heritage protection. Yeah, you might be able to argue for a representative, a type location, I suppose, that you could have on there. But yeah, mostly they're using it as a predictive thing.
thanks,
but
Susan.
Otherwise, yeah, talk to Heritage Victoria about that. They're certainly aware of it.
We've got another one here, which is related to the long-buried ceramic fragments. And were you able to determine dating of stratigraphy of the sludge with periods or types of mining that generated those particular layers?
Thanks, Paul. I wondered if you would see those those ceramics. We haven't used the stratigraphy for dating specifically, other than knowing the kinds of mining in a particular period, I suppose. So the ones that had those ceramics in that I showed you are probably from the 1850s and 60s, because that's when a lot of the activity upstream would have been generating that amount of sludge. And of course, that's when those pottery fragments would have dated to. But no, we have the geomorphologists did some OSL dating of one of the cores that we have. which, unsurprisingly said it was, late 19th century. But we haven't really tried to do specific stratigraphic dating of those layers that we could see.
Thanks, Susan. Are you able to see that one from Dennis? It's quite a long one.
Yes, okay. Subsequent use of the sludscape. Did this wholesale environmental change favor any particular later economy? Did it make it more attractive for sheep pasture or cereal production, or did it blight all uses equally? Pretty much blights them all equally. Cereal production, not so much in this area of Victoria, but not really because of sludge, more just because of, the mallee and the wimmera are just much better for cereal production. People grow lucerne, which is a fodder crop on these paddocks these days, we've noticed, and yeah, graze the animals on there. It would certainly have impacted any use of them for market gardens, and we haven't done any specific research to see whether there were any Chinese market gardeners displaced. I guess up downstream from Bendigo, there's very good evidence of the people there complaining extensively because they had orchards and vineyards in the 1850s, and they were very badly impacted by sludge and driven away by the sludge, and those areas were never used as market gardens again. So there, yeah. Up in the Ovens Valley is another interesting one where we have done some research more about the effect of dredging. I haven't talked about, but that made it more attractive for timber plantations because that was basically the only thing you could do with that land after the dredging in a lot of cases. So yeah, a general blight that did tend to drive things toward the lower value agricultural production.
Right, thank you. We've got a lovely compliment there from Caitlin. And then we do have another question just after that from Anne.
Yes, the contamination. Yeah, so we've been waiting for Francesco to finish his thesis so that we were sure of the results, because of course that is, very sensitive and important to get it right. What I have learned as a non-chemist is that there is a difference between the presence of a chemical and the bioavailability or threat posed by that chemical. And so that's what Francesco has been really looking into. And I mentioned, often those high arsenic levels are quite a long way down in the soil profile. So that's a good thing to start with. In terms of fishing and swimming, the EPA did a study in 2016 looking at fish in the areas most favored by fishers in Victoria and correlating them with their interpretation of where mining activity had been greatest. And they went and tested mercury levels in those fish. And so there are some places where there were elevated levels, and I think on their, the advice to fishers is they've got some information there, but you do have to have really a substantial amount of fish in your diet from that particular location before it would be a problem. And swimming wouldn't really be a problem. One of my issues with the EPA is that they didn't do very good historical research, so they haven't really looked at the places where mining actually was most likely to be putting things in the river. That's what our new project is doing. So we're working on that. So that's still very much, I would say, a work in progress about that.
And then we've got another one, which is really about the inventory and the register. And I think everyone should just lobby Heritage Victoria tomorrow.
Thanks, Siobhan. I'll tell Jeremy you said that.
Yeah, he'd be very appreciative, I'm sure.
He will be. Like I say, he knows about it. They're very, very aware of it. They are using it very, very much in their predictive modeling for the work that they get done. And not just Heritage Victoria, but First People State Relations. It has a big implication for the way that Aboriginal heritage survives and the way that people really should be testing these landscapes to see whether there is stuff there that they would otherwise have disregarded. Yes, in terms of lobbying Jeremy to protect sludge, I think he's very aware of the need to protect the on-site material. Yeah, we'd have to have a think about how sludge would be protected in itself. It's honestly so extensive. I don't think it's in any danger of being destroyed.
Yeah, and there's another follow-up question just below that one. The one
Yep.
from Grace.
Are there
Yep.
basic ways to identify mining sludge in test pits? I would say the first thing to do is to do your historic research before you're even putting in the test pits, because there are, it's very clear there's some areas where sludge is going to be more likely than other areas. And if you're in those areas, then that's when you would look for it in your test pits. And then the laminations, the color, the grain size, yeah, it's probably a good idea to do the geochemical testing as well. It will contain quartz because all of it is really quartz ground to larger or smaller sizes. I suppose that would be one thing too, if you were looking at the grains under a microscope. If they are from quartz crushing, then they'll be very angular or subangular. Whereas if it's just alluvial natural soil, it would probably be more rounded, those sands, but it's pretty much, yeah, there's a lot of quartz there. Mercury or cyanide contamination. Look, it depends where you are. Cyanide, as I said, is pretty much on site. So you'll probably see the evidence of the old cyanide vats. They did that around the beginning of the 20th century. So they used corrugated iron, like water tank kind of vats. And so you might see them, and yeah, the tailings around that. The bigger operations had big brick lined vats, and but yeah, you would know that you were on a mining site. The mercury, yeah, we don't know yet because we haven't done that research. We have a couple of PhD students who are just starting that stuff. Yeah, the good news about cyanide too, I should say, is that it breaks down very quickly in sunlight. So if it was getting into the waterway, it would break down quite quickly, as the water is moving. The stuff that is left in those big piles, the top layer, the cyanide will have broken down, but if you were digging into it, then there would probably be cyanide, yeah, underneath. And that's why councils do tell people not to take all this sand for their gardens and so on. But you could see that there's a long tradition of people on the goldfields coming with their trailers and collecting sand, unfortunately.
Okay, I think we've reached the end of the questions now. So I think we will be bringing this seminar to a close. But thank you once again to Professor Lawrence for making the time to appear at one of our ASHA seminars. Always fascinating, always fabulous. And I suppose my question to you about were you surprised was that you put it together in such a coherent narrative that it seemed like it was all thoroughly understood. So that's why I asked, had you been surprised? But
Yeah.
we're very grateful to you for letting us have this seminar in National Archaeology Week and making yourself available. Thank you very much.
Oh, thank you.